Okay, welcome to this session. I'm going to talk about Mimer SQL, and I'm going to talk a bit about our porting effort to this platform, some of the things we ran into and where we're at now. Okay. So I'm just going to start with a little bit of background about the product and a bit what it contains, and some things about the company and where we're from. Going into our latest release, which is the one that we have on OpenVMS, and then dive into some of the details of the VMS platform, and finally finish off a little bit what are we developing right now, and kind of you can see where we're going with this. Okay, the company is called Mimer Information Technology. It's a Swedish-based company. It was founded in 1984. So we've been around for quite some time. And we've been developing basically the same type of product all along. And we have customers throughout the world in many different industries, from dentists in Australia to steel mills in the States to hospital systems in Great Britain and so on. Very diverse. We're quite a small development team, but with lots and lots of experience, and we've been working together for many years. We're introducing quite a few young people as well now that we're all getting. So we're kind of in the same situation with VMS. You can see here where you can see the map lying behind there. Okay. So Mimer, who was this? He was actually a giant in the Norse mythology, and he guarded the Well of Wisdom. And the Well of Wisdom, that's actually a database. And so the gods came to Mimer for advice. And the main god Odin, he actually took out his eye and he put it into the well, because then he could see at all times what was happening. So, and I'm kind of thinking that high availability was important even then. That's a little bit short about the background about the name, because it may seem like a strange name for English-speaking people. Okay. It comes from Uppsala University and the computing center that served the different parts of the university with computing power. And they had lots of different machines at that time. So it actually very, very early on became a portable product. But it was developed initially on IBM 360 and then PDP 11. And then after that, VAX became the main development product and remained so for very, very long. Even today, we actually have developers spread over Mac, Linux, Windows, and OpenVMS. So everything we do kind of gets ported to all these 4 platforms the whole time. Obviously, we've been on all of these platforms. We're highly portable, as you can imagine. And we've had very good help from OpenVMS engineering. I guess we don't bother them that much, so we don't actually interact as much with them as maybe other database vendors. I think they appreciate when we come to them. So that's a little bit about the background about the company and developers. So let's talk a little bit about the product. From very early on, we actually looked very hard at SQL and SQL standards. So we've had a SQL compiler in the system since 1987. And at that point, the standard was very small. It was SQL 1 standard. And so we kind of built the system from that. And then over the years, the SQL language has grown, and it's a very, very large language these days. So we've actually rewritten our SQL compiler in 2010 with it, and for a few years we did that, to kind of embrace the complexity of the whole language that is. But we have for 35 years added functionality to the language, so we have lots and lots of features. I think we're actually the only database today that comply with the SQL standard Core SQL 2023. Actually, Postgres is very close now. They're only 2 features away, so they're catching up. Well, the database performance is, of course, very, very important, and scalability, both on CPUs and storage media and handling database caches and everything. So, but in our case, we're also actually working on very small platforms with very small amounts of memory. So, for example, we've been doing now the last couple of weeks an implementation that had triggers, foreign keys, constraints, everything, and the server was 500K. We can actually take our system and really squeeze it down. And if you look at database servers today, they're like 80 meg or 150 meg or something like that. And that's not suitable for that type of system. So we can actually be from the very low end to very high end. And that's also an interesting challenge when you're working with algorithms. How do you scale that? That's something we've done quite a fair amount of work on. Another decision that we made early on was that the system should be very easy to use and self-maintaining. During the 80s, everyone had system managers with white coats managing their systems. You had hundreds or thousands of parameters, and you could change all of these. And there were 4 experts in the world who knew how you could do this. But in our case, we actually, from the beginning, built into the system. It should maintain itself. It should adapt and make these decisions. So you don't have to take care of this. So that's the ease of use and self-maintenance and use parameters. If you then combine that with the database where we're continually maintaining the trees, there's an automatic reorganization. You don't need to run any utilities to maintain the database. Many vendors early on, they stopped their systems to do this. Today, they can do it online while the system is running, but it's putting a load on the system. But this is done in very, very small pieces by the system automatically. And so, for example, one of our customers, they're taking SMS that is coming in through this phone manufacturer, or what's it called in English, where they keep the SMS, and so they're all coming in, and then they're passed on to whoever the SMS should go to. So a lot of data streams through the system at very high speed. So continually it grows. You insert data and you remove data, and with the reorganization, it just stays there and maintains itself perfectly. Here are just a few of the platforms that we run on. We've been on maybe 50 or 100 others also over the years. So it's very, very portable system. Yeah, here is some details about the reorganization, where you have you never get overflows chains like this in the system. It's always the same depth from the root to the data pages. It doesn't matter what type of operations you do towards this. Always maintain the tree balanced, and the pages will be filled accordingly. And that gives you very even performance, and there are no surprises. It doesn't work badly on Friday afternoons when you had a high load during the afternoon, because these overflow chains appear and you have to have someone clean them up manually or automatically. Another thing that we have, I'm just picking out a few of the features, obviously. There are tons of things to talk about here. So I picked out some that I thought are interesting. We have some customers with large databases. There are many with terabytes of data. And it's really important that if a system goes down and you have to take it back up, that goes very, very quickly. So we've developed something called immediate restart. And we tested this at a customer site. This is the National Health Service in Great Britain. They have a huge database with all the donated blood in the country. And so after we implemented this feature, we asked them to kill their system and restart it and measure how long it took to get back up and running again. And they said we could not measure any delay at all restarting the server. Could immediately, we started it and then it was up and running again. Obviously, you had to page some data into the database, but it was there and doing its work directly. Here's another thing that we've built into our database. That's how you sort data in different countries. This may seem trivial, but it's actually very complex. We actually corresponded with professors at different universities to find out the correct sort order for many of these languages. Sometimes it's easy to find out, okay, so how do we sort the letters that are for this country? But for example, how do you sort an Icelandic letter in Sweden? Or how do you sort an Icelandic letter in Greece? And so it's not just getting you have to get all of these right to do. Other things are that, for example, in Spanish, the letter L, if you have the letter L followed by an L, that's sorted as a single character. In other cases, you have a letter AE in Danish, you can sort that as the letter A followed by E. So sometimes they expand and sometimes they contract. There are even some Arabic cases where it expands to 7 letters from a single character. And we've also done lots of stuff regarding Chinese and sorting and pinyin and things like that. So, and all of these things are really easy for the user to use. You can just say collate Swedish without case. So that's the Swedish 1, or collate Swedish 3, then you will get with accents and everything nicely sorted. So typically when you compare, you use the _1 sort order, because then it doesn't matter if you've written it in upper or lower case or accents or things like that. But then when you want to show the output to the user, you want them nice and neatly sorted, where accents are after the non-accented letters and so on. So You can kind of combine these things nicely. And you can index with collation, so you can get full performance with these things. Okay, that just a quick give. Picked a few features to just show you what we can do. So let's talk a little bit what we've done. We've actually done some benchmarking. We haven't actually before done a lot of benchmarking against our competitors, but we actually ran into a number of customers, and they said you have to run these benchmarks and show us that you're better than the others. So that's what we set about doing here. And it's kind of nice because we're really looking at this from two perspectives. One is looking at query and query optimization. That's one area. The other area is transaction handling and OLTP and hitting the system with lots of load and lots of transactions and being able to handle that efficiently. These are two quite different areas. So we've actually done two different benchmarks showing this. So this is TPC, which is the Transaction Processing Council. They have a online analytical processing benchmark called TPCH, and they have 22 queries that they've set up. They've decided exactly what the data should be. All the vendors have worked on this benchmark and tuned their systems for it. So I think it's fair in that respect. So we've given them all equal amounts of memory. We're running on the same hardware. They have the same indexing. So everything is really trying to set everything up exactly. Exactly the same. We cut off this here because MariaDB went to 976 seconds on Q13. It was not really happy about that query. But you can see here that these queries they've really put some thought into them because they represent really different challenges from an optimization point of view. But not only that, you really need to have a fast execution engine to handle these things. They're doing lots of complex aggregations and lots of numerical computations and divisions, and so there's fair amount of complexity going on in this.
I realize you don't probably want to advertise which vendor it is, but can we presume it's one of Sybase, Cache, or Oracle?
Yeah. Yeah. Actually, I was quite impressed by them. I didn't expect them to be this good, I must say. The blue is doing quite well here.
And it's covered with most categories.
Yeah, yeah. I have a summary here of all the total execution time. And you can see that we are better than them, but some margin at least. And
But both way better.
yeah, but the others are not doing well. So this is query optimization and query execution. Just and in a way you can, if you think about this, let's say you have, well, when we talked about the cloud and we're putting our databases into the cloud, you're actually paying for this, running the same query. I mean, this is really the bill that Oracle Cloud will send you that we're looking at here for doing these queries. The other, oh, where did this come from?
Yeah, move the mouse.
Okay. Okay. So now this is not, now we have a reverse situation. Now we're looking at, okay, so how many transactions can we get into this, make this system handle at a time? So now we want to have high graphs. And this is something called Benchmark SQL, which is an open source benchmark. It's taken TPCC. TPCC is the Transaction Processing Council again, but that benchmark is rather complex because you have to set it up with delays, and you have it's quite a feat to implement and execute that. But Benchmark SQL just takes the exact same load and the same database and just lets everyone hammer away at the system and see what happens, rather than having more clients with less doing things with think times. These tests are actually, they're also quite difficult. They're, for example, you have these 64 warehouses. They are represented by 64 rows. And every transaction that you're doing is updating one of these 64 rows, because they're keeping kind of a accumulated count for the warehouse, which means that you really have some difficult hotspots in this system. And of course, that's one challenge for an optimistic concurrency control, and also a challenge for a locking system. So it's not, you can see here that what you measure in TPCC is the TPMC, but then there's a load. I think there are 4 different transactions running concurrently to get a natural mix on the system. So you're not just doing one thing. And then they're measuring one of these. You can see that we have a really high throughput through the system. So we can handle both OLTP and query. So we were pleasantly surprised by this, because we had not taken the time to do these benchmarks before. So we're really happy. All these tests were done with this version. So this is just give you a few things that we did in version 11, which is the one that's been released and that's out on OpenVMS now. Basically, we removed a lot of limits that we had in our system. So the database cache had a limit of 16 gig, which is not enough today when you easily you can have a terabyte on main memory. And now we can go up to 327 terabytes. And the file sizes had a limit of 8 terabytes, and that we've also increased to something enormous, petabytes, or it's actually 4 exabytes, if anyone knows what that is. In any case, it will be the file system or someone that's not us that will limit how much can you store and how much can you handle. So we actually changed our internal storage formats and block sizes, and we'd actually not done this type of change since 1989. We've been compatible with the database format, and we felt we cannot scale up unless we do this. So it was the first time in a long time we could do these things we'd only dreamed about.
Obviously, in 1989, 16 gigabit cache and 8 terabyte files really huge.
Oh, absolutely. I mean, they were looking like these figures now, though. Yeah. Yeah, here are the more, you have some SQL 2023 core compliant plus 145 more features in the standard. Okay. One thing we also introduced, we had a concept called a data bank, and a data bank was a file in the operating system, or maybe a raw device on a Linux, well, at least earlier, file systems do not handle large files well. And a single table in the database was always located in one file, both the table and its indexes. The reason that we chose to have them together is that it's easier if a disk crashes, for example, you bring in a backup. It's a hassle if you have indexes here and so. But this gave us a limitation on scalability. So we introduced the multi-file data banks, and you can actually have a system running today, and you can online add another file to the data. So a funny thing about it was you could actually move the database because you had a file on this disk, and if you didn't want it there, you could just add a file here and then remove this file while the system was running, and it just did this concurrently with everything else. That's how we do everything to keep availability up. But it's also really nice because if you look at a system, either you're running out of CPU or you're running out of I/O typically. But with the multi-file data banks, you can actually do something about the I/O. You can then add them and the system will automatically balance the data in the files. So you don't need to do anything. Again, we're kind of thinking, let's do this for the user rather than having that controlled by someone. As I said, we've actually, with version 11, we had this new the storage system was revamped in our system, and the SQL compiler was new. So even though we've actually worked with the same code base for so many years, it's actually very modern and well kept, which is great for us because we can actually do things really fast and implement new things easily. Yeah, I have a session on database security coming up, so I'll be talking about security, but I'm just going to pass through some of it. With the client server, again, you have to think about how we deal with the design of things. What you do if you want to have client server encryption, you set a parameter for the database server and say encrypt all communication. And that's all you do, and then you just run. It's completely transparent for the application. You just do the setting, and then this will happen. It uses standard algorithms for encryption because then you can get at the hardware support for this. It's really, it's really, really fast. And it doesn't cost. You can hardly measure it actually. So there's no reason not to use these features. And in our case, you actually get, each session gets a unique new encryption key. So there are no certificates or stuff for things that are difficult to handle or expire. Yeah, I'll talk about how you can get protected with some cases. And just mention this here. We also made support for an in-memory server, so you can start with whatever database you like on disk, and then it will just, now that we can have large main memories, you can actually have an in-memory server. So you can run any application, and we actually run our tests sometimes this way because it's super fast. because nothing gets written to disk. And you can do all these commands. You can do create data bank, and we'll say, okay, I created a data bank, but it didn't actually create a file. And then you can, so all the commands that you ordinarily do towards Mimer database, all the SQL and everything, you can do towards it. So it's completely transparent for the application. It just runs really fast, and nothing's written to disk. There's one exception now. You can actually take an online backup, and the backup will actually get written to disk. So you can run with this system, and then you can take a snapshot of it, and then you can start from that if you want.
So obviously, historically, it would be a lot slower to be disk than it would be to go to memory.
Mm-hmm.
In a modern high-end server today, is that still true?
Yeah.
Even with the solid data?
Yeah, it is.
Okay, I hadn't done benchmarks.
Yeah. But I mean, obviously the difference is less than it used to be.
Right.
Yeah. We also work with a company called Trustonic. They make something called a TEE, a trusted execution environment. And this is kind of a little hardware contained software environment or operating system. So for example, on your mobile phone, when you enter your PIN code, then you're running within the TEE on your phone. And so Android cannot see what digits you're actually typing on the screen. So you're kind of trying to separate very important things through the trusted execution environment. And what we've done is that we've actually, you can write something called trusted applications that runs within this environment. For example, the application getting the PIN code is a trusted application. So it runs within this contained environment. The problem that Trustonic has had is that it's very hard to see what's inside of these. So, but now that we've been able to hook up the trusted environment to the Mimer server, you can actually run for example, a result set procedure in the server and pick up data from the trusted environment. And I'm going to show some examples about that because you have many really interesting applications for this. You can actually sign data, because sometimes it's really important to know that the source of the data is safe and also that the data has not been manipulated. So for example, you can have a car running and you can figure out, okay, its position is here, and that's kind of created within the trusted execution environment. You can pick this up and put it in the database together with a signature. And then you can pass this up to the cloud, and you can still know that no one has manipulated this. The taxi driver, for example, that we're looking at here, he cannot in any way get to this data. If it changes it, we can detect that. So there are lots of interesting possibilities. Okay. I'm doing pretty good. Let's talk about Mimer on OpenVMS. As I said, we've been developing on OpenVMS or on VMS to begin with since 1984. So it's actually 40 years now. I remember my first Hibernate Wake multi-user system. It's called the Turbo system. When we did a shared memory communication, that was in 1985. So. Yeah, let's move on here. We're actually the first database that was up and running on OpenVMS x86, And you can see that was 1.5 years ago, with all our competitors struggling to deliver something here. We made a second update at the end of last year, and now we've actually made a release. And both of these were made with the cross-compilation kits. And we've had some of our customers been playing around and doing things with it, but I think for most customers, it's a little bit too much of a hassle with the cross-compilation. So I think now that we're talking more native compilers and that's starting to work, that's going to be a lot better. In our case, we've actually made parallel Itanium releases with the exact same source as we had on the x86. Yeah, so the first two we called them beta releases, but actually this release was a production release on Itanium, but with the compiler not being really up to speed, it was working, but not well enough. We call this a beta, but this one is actually a production.
Yes.
Okay, I'll talk more about my experiences, and I have one or two issues. This is our client support on VMS. We have a JDBC client for Java. We have an ODBC client on Windows and other platforms. You have an ODBC driver manager, but that has the same interface as the ODBC drivers underneath it. So, but on VMS, you actually link directly to our driver. There's no driver manager involved. And then we have embedded SQL for C, Fortran, and COBOL. And we also have support for module SQL, which is you just make calls to routines. You put all your SQL in a sequential file, and for each SQL statement, you give it a name, and then you call that name. This is very popular for Oracle RDB customers, we found out. So that's actually why we've added it. So it will be easier to convert RDB applications for us. By the way, I actually looked at RDB's SQL support and looked at all the standard features that they have in their system. And we have all of those features too. So if you're sticking to standard SQL and using RDB, you can actually move straight over without changing those things. Then we have a Python client. We also have other languages like Rust. I don't know if that's something that, but I think that's a very, very interesting language, actually. Has some very interesting properties for both operating systems and database systems too. There are some difficulties when you're using C with regards to shared memory and memory consistency, and by magic they've actually removed these in Rust. So you actually have a language that take care of some really, really difficult and very hard to find issues in C when you're using shared memory. So actually some part of the Linux kernel is now being rewritten in Rust. So I'm pretty confident that we'll get all the performance that we need, but we're kind of removing some really difficult issues with regard to memory handling. Not saying that you cannot, if you know what you're doing and really have control, that you can do this properly, sure. But it's nice to have a language. Oh, that was a digression, sorry. I hope to add our Rust client to the OpenVMS interface. Yeah, on VMS, we have many of our customers have quite large production systems, so being able to do monitoring and stuff, that's important. We have T4 support, which is something used by VMS to log system, how is the system feeling and what's happening. And now you can add the database stuff to the T4, which means we can both look at the system in general and the database in specific. Yeah, which is great.
Oh.
You can make graphs and you can understand, okay, we're seeing some lower response times here, but we're getting.
It's invaluable.
Yeah.
Because way back when you used to be able to, you still can, you know, have codes. T4 had support for an RDB plugin. So they would run, you could run an RDB data collector, and then there was actually a converter.
Okay.
So you can look at things like index searches, or you can look at things like index search is the only thing that comes to mind right now. And you can see, okay, at this point, I spiked, and then you take the T4 disk data and you overlay it over the same graph. And
Yeah.
You see, hey,
Yeah.
this system disk, this disk that the database is on is real busy. It's
Correct.
busier than the
Yeah.
index search. What else is on there? And you go look for another peak.
Or you see that, oh, all of these processors are
Yeah, and then you go
suddenly
look
very
for something else, and you
active.
say, son of a gun, I didn't realize that these two database areas ended up on the same physical side. No, when you move them.
Exactly. With the add file, you
Yep.
could do it on the fly, right? The SQL monitor, you can then also look at specific SQL statements that are even more or less expensive when you're running them. So we have them. Let's see if I have another one. Yeah, we actually have graphical sides to this, so you can actually sit on a Windows box and get a graph with the SQL statements.
Your VMS-based SQL monitor, is it command line or does it use something like Windows, X Windows?
No, it's command line.
Okay.
But so if you want graphical stuff, you go to Windows and then hook that up to your OpenVMS Mimer database solution in the cloud.
Oh.
No, Oracle lets us into their cloud. Hopefully. Okay, let me talk about some of the experiences then. VMS as an operating system for us was very, very stable. We had some initial problems with pthreads, which we're used to. We were their testing station for pthreads. We had really big problems with the debugger. It never worked initially, and it's becoming better. It's still crashing, but I'm being told that the next version is really good, so hopefully. But in our case, what happened when we did this cross compilation, we ran our test suites and we had a problem. We almost always had the same problem on i10 as on x86. And that's, if you think about it, that's amazing. I mean, that's true compatibility. I mean, I don't know how they did that.
The
But
same thing wrong the same way on both machines. I love that.
yeah, so we debugged it on i10, we fixed it, and then it worked on both. So that's really how we did the initial port. I mean, we were early adapters or whatever it was called, and so it was. But we could. That's actually how we could do it 1.5 years ago. We have our source code in Subversion, and the reason for that is that we haven't had a good Git interface on VMS, but now they're leaving us behind. So now maybe we could actually move over. We actually have most of our source in Git, but not the main repository. But now we'll move that over. But we could actually, even though Subversion is not working from BSI, we could use it through JSVN, which is a Java subversion. So we could work around this problem. And as I said, we've been using the new optimizing compiler, and it's much better. And as you can see here, that some of our tests are running twice as fast, which is
that compared to the non-optimized compiler?
no to the. I'll know that's compared to what we had with a cross compilation compiler, which essentially didn't optimize your code, I guess. But
No, that's completely true.
yeah, so it's looking a lot better. I know that there are more things coming. And I mean, we're also making like a compiler with a SQL compiler, so we know that you can always tweak a lot of things to get things faster. Doing the work cross compilation is a hassle. It's much more difficult. Actually, today there's only one thing that's remaining for us to actually do the whole release on x86, and that's we're signing our executables, and that has to be done on Itanium, I think. So we can.
We have a signer on x86, but it hasn't been through any tests yet.
No, okay. But we're kind of, it would be nice to have that last piece,
Yeah,
because now you have to move everything over, assign them, and kind of, yeah. So, yeah. Debugger somewhat unstable, signing on it. Yeah, so that's, we still have one problem with, sorry?
Let me know if you want to be a test bed for signing on.
Okay, yeah, please, yeah, we do. In this release that we made the other day, we actually compiled the whole system with Optimize, on this compiler Optimize, except one file. And it had to do with set jump, long jump. And I talked to John about this, John Reagan.
This was the C76 compiler with the /optimize switch?
Yeah.
Okay.
But he said there'd been a correction in the C runtime library that he thought could be this issue. But we're kind of passing things around to resolve this last one too. It's okay to have one routine in non-optimized. Everything was in the last version. So. Okay. Okay, let's see where we are in time. Oh, this is working out well. I'm glad you took so much of my time, Camille. Okay. We've done a lot of stuff actually since we released 11.0. We've implemented encrypted database files. I'm going to talk about that, how we've done that, and how we can do it. We've implemented grouping sets, which is kind of advanced aggregation functions in SQL. We've implemented temporary tables in SQL, so you can define a temporary table in a dictionary, and whoever inserts into it gets his own copy of it. And then when the session ends or the transaction ends, you can choose that the temporary table is empty. Results. We are implementing SQL window functions, which is kind of like, for example, a running aggregate or running some more Excel-like functions to SQL. This is quite ambitious within the standard there. You can implement a lot of stuff, and there are some tweaks that make them a lot of work to do all of it. In our system, the system manager had the name sysaliam always, but that's kind of an attack vector for someone trying to hack into us. We're making the name user-defined. We're doing improved failover. I think that's an interesting area. I'll talk a little bit about that. And we've done some indexing enhancements. And then we can call procedures. And this is also something we've finished to these three basically. External .NET procedures. So you can actually write your own code in C# or some other .NET language, and you can have that, you can call that function from within your SQL statement. So you can have a function. And this is a good way of interacting with AI packages or doing more advanced things like that. Or if you want to do things that we don't want to support, like emailing someone, then you can kind of write your own code or do whatever you like out there. So let's just talk a little bit about failover, because that may seem like it could be that the machine stops or database server stops, and now we just restarted with the immediate restart. And so what happens now? What's the impact on applications? And all of this is really related to transactions, because if you have a connection to the database server and you're not doing anything, and it just switches and uses a new fresh server, then we can hide that completely. If we just remember what SQL statements you had handles to, we can just recompile them under the covers. But if we're in the middle of a transaction, we really have to tell you that, oh, your transaction was rolled back. You have to restart your transaction. And this is typical for any application that may be able to do this. And so we're kind of taking care of the error handling to make it easy for the application to detect that we're in this specific case. You actually lost your connection, you have to redo.
I think what you want to say in that last sentence is not restart a new transaction. I think you want to say restart the same transaction.
Yeah, that's right. Yeah, that's right. Yeah, that's correct. So you retry your current transaction. But then you have a slightly more difficult case, and that's if you're just committing your transaction. And that's where we need to help you. So we've actually figured out how to do this so that we can, because what happens is that we're making a call to the server, but we cannot really be sure if the server took this request before it went down. And if it took it, we don't know if it actually committed the transaction or not. Or it could even be that, we're doing an auto-committed insert, for example. Was that insert done or not? And it's really difficult for the application to, if we just told it, we failed, you have to check if your transaction was done or not. That's almost impossible if you have a multi-user environment and things are happening and banging on your system. So what happens is that we know that, we can then, when we reconnect to the new server, we can ask it about the transaction we were about to do. So the server that restarted will know if it was done or not. So we can, after we lose our connection, we reconnect, and then we ask the server what happened to our transaction. And then we can tell the application it was rolled back or it was committed. So and that really helps from an application perspective to handle this.
Is there anything you can do? And this is a failing that I've seen in like every SQL-based programming application I've ever looked at. They're very good at checking, well, did this insert succeed? Did this insert? They don't have the concept of having to go all the way back to the top and start over again.
No, right.
Is there any way that you can look in the transaction log and say, okay, everything was done, the commit was done, everything you still need to actually replay the transaction is in the transaction log? Can you just go forward from the start of the transaction?
No.
Okay, easy answer, thank you.
Yeah, you have to redo the application. from the application point of view, because what happens that someone actually did something to something that you were working with. That's
Okay.
why you failed. So
Okay.
presumably you need to know about that. Yeah. Okay. I'll hurry up here. Yeah, I think I've explained, I went faster than my. Maybe we should, you guys want to take coffee now, or let's see what we have.
Yeah, I need to.
Yeah. Yeah, so here's the procedure server. You cannot keep it within the same address space as the database server because it has privileges and stuff. So that's out of the question. And also, if someone writes some crappy code here, we don't want this code to be affected. So there are actually two reasons for doing this. So here's my example. And we have lots of stuff on the web. This was in the spring, so it's a few more probably. So that's it. Okay. Thank you for listening.
Have you found that many people that were running on 10.1 have made the change to the methods that were running on OpenVMS? Have you found a majority of people?
Our customers are very slow to upgrade
Yeah, that's what I
because they have these production systems that they don't dare to touch. So it takes 3, 5. They want other customers to do it first,
Yes,
and
yeah,
then
we want to be the first.
yeah.
Yeah.
So not the. There are some that has upgraded, but not definitely not all.
10.1.
Yeah.
Also, yeah.
Could I just look at your deck again from the beginning real quick?
Yeah, sure. You wanna? Maybe you can.
Yeah,
go
that'll
to
be
where
fine.
you-
That'll be fine. No, what happened was I got shanghaied on the way in here. Just so based on my agenda. There we go. That's going back to the beginning. Oh, that I did not know. Are you by chance a Stargate SG-1 fan? The science fiction series?
I've seen it, yeah. I'm a science fiction fan.
Okay. If you look at the systems that I work with, you'll figure out that the names of some of the x86 servers come from the Norse gods.
Yeah.
I've got one called Thor. I've got one called
Right.
Freyr.
Okay, great.
There's a whole Lord of the Rings thing going on too in the data center.
I guess you will have all of these.
Yeah, this is fine.
Okay.
So how is this thing licensed? Or,
Well,
I mean, can you, I haven't honestly looked at this thing in a long time. I mean, can you go to the website, pull down a distribution kit, install it and start using it? Or,
yeah, there's a development license. It's only if you put it into production that we would like to share.
okay, that's terrific.
There's a,
That's terrific.
There's development for Windows and
Yeah.
everything else, yeah.
Because right now I'm trying to decide whether I put my model train RFID tag database into either Mimer or Shark.
okay.
We would recommend mine.
I was no
I'm
doubt.
just gonna take a look here.
Oh, this is for my next session.
You're gonna do the next session, this is the same thing?
Yeah.
Okay, cool.
It's security. Yeah, that's the one. Oh, thank you.
So they're on the
I
desktop.
was so glad everything was set up for that game. Thank you.
Yeah.
It's recording, so we're good.